I'm using the language English. I hope that's okay with everyone. Hi everyone. So today we have gathered here to understand full stack development. This is going to be an overview session. So we will not really go in depth of any one topic particularly. Uh, yeah. So moving on. What we'll cover in this session is overview of modern software development, and in particularly to that, what is a full stack development. And within full stack, there are some components over which those are the major components. We'll talk about those components. So there is front end, there is back end, and there is DevOps. And post that, we'll do the question and answer session. This is about the speaker. I have almost 2 decade plus experience in software development architecture, and I've been part of banking, automotive, healthcare, embedded systems, IoT. And my core skills are architecture, design, programming. I still code. The way I said, I'm software architect plus coder, so I still code day to day, as in day to day activities. I have also got into generative AI in last couple of years, and we are developing RAG pipelines and agentic AI now. Uh, yeah, so that's about me. So modern software development is really something like running a smart city. So if there is a big project, for that big project, we will need something over which users will interact. So if this analogy has to be applied to a smart city, then all the streets, parks, and buildings, they are really something like the front end, the things that people use. Right? Backend is something that runs the city. That means the utility, the power, water, traffic, and all of that thing is more like a backend. Uh, Database is a place where we keep all the goods, all the information is stored, so that even if the power goes off, there is something to hold that warehouse, something of that sort. DevOps is something like the maintenance, or if we have to plan expansion, then that's about that. Testing is about safety inspections tools, like cranes and trucks and computers. And Agile, how the city council plans and prioritizes some work, right? Like we feel that there is a new community coming in some area. So then now we're going to plan few things over there before the community comes there, right? So things like that. Uh, the reason why I'm giving the analogy, because I felt that there are people from other domain who probably are new to the topic, and that's where I've kept it as that. But if you feel right now, I know Amol sir, Mohit, Praveen sir, Rahul, Sanket, Satish Vaibhav, and Vishakha. All of you are from IT background, so I will try not to give the generic analogy at this point of time. So this diagram I've created. um so we'll run through this diagram. So idea behind this diagram is not to take you in depth of every topic, but just to understand the gist of what components primarily are present. So we have this front end. Front end is basically your mobile or desktop or any other device, really, for that matter, that uses your web client, like your browser, through which we would access the front end application. So web client have become a kind of integral part of even the desktop applications, right? So we are showing that. And another thing is, this is a typical web application scenario. So this architecture may not apply to all the things. So depending on requirement, depending on the domain that you are in, things might change. Okay, so you may not have web client in some cases. You may not have this CDN. You may not have message queue. So these things might occur. So this is a very, very typical stereotype kind of architecture. So it is only to give you the idea of the topic. Okay. So this is the front end. It has the base technology of it is HTML, CSS, and JavaScript. And on top of that, various frameworks are developed like React, Angular, Flutter, Next.js, Vue, and Bootstrap, and many other frameworks are there, right? How your mobile connects to the backend is through this server. So this yellow part you see is a server. And on this server, there are various components, starting with your cloud server where uh, all the infrastructure basically is placed. And here you will have a DNS. DNS is domain name service, which will convert your URL into an IP address, right? So that job is done through DNS. And there are web servers. Web servers, like because you have this web client, it has to talk to the web server. So there's a web server. And there could be a series of web app servers as well. And these application servers could have multiple applications running on them. This for front end, like we can say that the front end is running on one of the web server, right? We also need for scalability reasons, scalability as in if just imagine that there is a cricket match and everybody wants the update about the cricket, right? So that time the millions of people would log into that server. And that's where we need to make sure that the load that is coming onto the application is distributed among n number of different servers which are working in the backend. So this application load balancer comes into picture. There is a API gateway. It has numerous functionalities that can be implemented. And nowadays there are a lot of standard applications frameworks around API gateway. And there are backend servers. The way I said, the none of this front end or the application gateway or the application load balancer really serve the request. So how this works is the client sends the request, the server prepares that and sends it back. It is very similar to a hotel scenario. Like the kitchen is something like backend, and the order placed and the tables are the front end where users come and they place the order. So that order goes, it is prepared at the backend in the kitchen, and that is served back to the front end. And while doing that, there are numerous resources, there are numerous database and few more things, infrastructure that the kitchen would need in order to prepare, right? So they probably are keeping vegetables in some storage, right? They probably are keeping some other, notification also they need. Like internally, they have to notify, yes, the order is prepared, now take it, and things like that, right? So those kind of things are present in this. So these are backend servers, and the backend server also, this is one of the backend server in which there are typically these components kept. There is a API management, there is application code which would eventually may use multiple services. There is a storage. This storage will make use of this something like your database server. It will connect to the database server. It could be SQL or no SQL server. There could be a cache. So Uh, and there is a user management. User management is about authentication and authorization. There could be an entity called as identity provider, IDP. This could be something like your Google. So whenever you log into any uh, any application, for example, LinkedIn, you are given option to log in through Google or Microsoft or Facebook at times, right? So they are basically identity providers in that case, and the authentication happens through them. And the authorization is something like, even if the user is identified, the authorization is the part where we decide whether the user has access to that resource that it is asking. For example, if uh, in the hotel scenario, if the person comes and he orders few items for which he should not have access to, for example, he wants something like carrots, right? Raw carrots. Hotels don't serve raw carrots, right? You can't, it is not really a vegetable market kind of place, right? So even if carrots are there, those will not be supplied to the user, right? So such authorization, checking of access has to be done. So that happens somewhere in this backend service. There's a configuration. There are multiple configurations, policy-based implementation that we have to adhere to. There are a lot of parameters based on which the application has to work. Uh, so that is maintained in configuration management. And the security aspect is definitely there. Anything like at all levels, the security has to be implemented. So security really happens on the web client as well. It also happens on the web server. It also happens on the API gateway, and it also happens at the application level as well. And the same thing is implemented at all other components. Okay. And there's infrastructure. Infrastructure means basically all the compute or your memory and database size and everything that has to be managed. So to some extent, the backend, as in the framework with which the backend is implemented, the application is implemented, that also has to take care of infrastructure part. One quick question. Are we going fast? Are we understanding? Can somebody please unmute and say if this is okay? Okay. Thank you. Uh, so sometimes these backend applications don't just work on the things that they have. Sometimes they have to talk to some external third party application or some application through which they have to send and receive the data, right? So that is something outside territory of this one cloud. And sometimes it may happen that within the cloud there are multiple networks where these components could be kept because they are shared. There could be something um, like logging is done on some different network, right? It may happen. I don't know. Message queue is something to send and receive messages between the components. Like I said, this is just one server. Maybe now here we are showing three servers, right? Maybe this one server has to send message to the other server, and this also is sending a message to other, right? So they work in line with each other, and they carry out the work, and then they serve the request sent by the client. So message queue is for exchanging information. Notification is to send notifications to users. For example, you are sending your OTP, right? So OTP sending thing, or maybe some in an MFA situation, multi-factor authentication situation, users have to be notified via email. So that is done by a component called as notification server, right? There could be logging, there could be cache, and there could be something like secrets manager where your application and your infrastructure has to keep some passwords, very application specific passwords, system specific passwords, or any codes secrets, they are kept in this. And there is identity and access management that happens. Yeah, so this is here only. Sorry, I think I should not have moved it here. It is somewhere over here only, access management, which does the authentication and authorization job. And the new component recently got added in this entire architecture, and that's Gen AI. And that's where your RAG pipeline and many other things have come into picture. A lot of work regarding messages, regarding getting the response, regarding searching few things, or rather preparing the response. We don't. Can you just look? No, no. I hear the sound. Right. That's Gen AI component for us. And this is not the entire picture. There is a monitoring stack. So there are few components which collect these logs, and they also let the admins or you know they can also prepare some view that your data analyst or business analyst could make use of. So there is a monitoring stack that works to prepare those views. And the stack, like we mentioned here, there's HTML, CSS, and JavaScript, and on top of that, we have React, Angular, and things like that. Same thing would happen in backend case. The technology that we use to write these applications could be .NET, Python, Java, Node.js, PHP, C++. There could be SQL and NoSQL in terms of databases. In terms of your API gateway or application load balancers, we may have components from Apache or Nginx. And regarding messaging queue, we may have Kafka, SQS, ZeroMQ, RabbitMQ, and things like that. So yeah, these are the components. If there are any questions regarding the functionality or the use of any one of or all of the components, really, please share your queries in chat window. Okay. Uh, Right. So the way I said, the front end, the modern software development core layers are front end, which is the UI design. Accessibility is a very important aspect of it. Accessibility means if the application used by a physically disabled person, then they also should be able to use that. So there could be a audio for folks who are blind. They could access the application, for with audio, right? And there could be special instructions for that. There could be some folks who may are colorblind. So the UI UX team have to make sure that the colors are shown in such a fashion that the even the colorblind people are able to see your application, right? So those are the accessibility aspects. Responsiveness means your application has to um, respond in time and also respond to multiple devices requirement, because your application is going to run on mobile or tablet or a desktop or maybe a very huge screen, depending on application. Yeah, and the performance, so these are primary concerns when you are developing a front end application. And the technologies we have already seen. Backend is actually the process. It requests sorry, it processes all the requests coming from the client side. So server is basically server doesn't do anything unless there is a request from the client, right? There are very few cases in which the server sends messages back to client. So for that, we have to keep a channel open between the server and the client, because client could be anywhere. Like server is at one place, but client could move from network to network, right? So it's very difficult for server to keep that connection with the client at all times. And so that's where you need a special machinery to interact, to send and receive messages between server and client, especially from the server side. Right? And all the business logic is here. It talks to databases, and there are various technologies that are used there. Database, we have storage and retrieval, and there is a PostgreSQL, MySQL. These are different tools. There is MongoDB, Redis, and there is also graph databases like Neo4j. And yeah, I think we'll not go into the concerns of this. This might take some time. And this all relies on infrastructure, and there is a role called as DevOps who make this all happen. So they make sure where the code runs and how it can scale. For example, the way I said, some applications, some websites, probably only 100 hits it may have in a week. And there could be times when within a day, there could be millions of people hitting that website. So they'll have to take care of scaling. Uh, and our government websites definitely need to work on these scaling part. Uh, yeah. Uh, so this is a development process. What typically happens is there's a planning, and for planning, planning is basically understanding the requirement, creating the stories, basically breaking those requirements into small modules, and then defining the acceptance criteria so that the development team, design and development and testing team, and also the deployment team understands how exactly they have to work. Please let me know if I have to slow down, or if everything is okay. If yeah, uh, UI UX design means you have to prepare the UI. So there are tools like Figma. where before the application is created, a prototype of it is created in diagrams. So those diagrams are created, like where the button should be, what will be the color of that button, and clicking on that button, what should happen, which next screen should be seen. So all of that information is prepared during the design phase. Yeah, this design could be UI UX design. The architecture, the way I said, this diagram is architecture diagram. So we prepare that at the start of the project. And there is data modeling. The data part in this SQL and cache, or what should be kept in secrets, what should be the design or the format of the data. All of that is decided in the data modeling aspect. Then actual implementation happens, in which developers, coders, they write the code and they interact with each other on something called as APIs, application programming interface, through which these applications talk to each other. And while doing that, they may have to talk to databases and may change few things on the schema level. Uh, so we call that as database migrations. Testing would happen automated or manual, depending on the project that you are in and the complexity. There could be automated checks as well. Nowadays, there is a lot of focus on automation testing. And that's where if we have any QA on this group, I would suggest them to look into this as well. Deployment, the way I said, even if you write everything, that has to be put somewhere, installed somewhere, and there should be every software has to change, right? So those change has to be incorporated in a very smooth fashion. So for that, we have something called as CI/CD pipelines, which push those changes onto the servers without really affecting the user interaction. So we have some tools for that, monitoring and feedback. The way I said, there is an entire monitoring stack and process, and a lot of data views are created. They are not created when your application is running, but after the data is collected, we there is a lot of processing that happens on top of that, and the industry of data analysts and business analysts and the views and the presentations, they all rely on this aspect, very important aspect these days. uh, yeah, so what roles are there? So there is a front-end developer role, full stack back-end developer role. They only work on the logic and the APIs, only work on the back-end side. Full stack developers do both. So if you see in this picture, it is not really possible for one person to do everything. So full stack developer role really applies to projects which are very small in nature. If the project is a big size, huge size, like an enterprise size, then you really can't have a full stack developer. In that case, a full stack developer may have understanding of all the components, but they will eventually have to focus on few aspects of front end or few aspects of back end, right? So yeah, so having that understanding is more important, and that's what even companies are currently looking for. So full stack developer, DevOps engineers, they handle the infrastructure and deployments. We've seen that UI UX, they make application usable and beautiful. So again, very important from market perspective. There are applications which are very nicely written, but because their UI UX is not good, they are not usable. So it doesn't matter if your application is very strong, stable, scalable, performant, optimized. But if it is not meeting the user's requirements, if users are finding it difficult to get things done, then it is of no use. So this is again another very important aspect of software development. QA testing, yes. Product managers, they define what needs to be built, how it and why it needs to be built, and they also interact with many other stakeholders, right? Who are going to use the application. Scrum Master, Agile coaches, they keep the process running and they make sure that everybody is on their toes to complete these things, and everybody, because these are multiple pieces moving, right? Because this is getting developed, this is getting developed, this is getting developed, this is getting developed. All of these things are getting developed in a parallel. They're not sequential. It doesn't happen that the front end is developed first, then the back end is developed. Nothing like that. Typically, what happens? Yes, there is a sequence to it. The backend APIs are developed first, and then the front end team starts working utilizing those APIs, right? So that may happen. Yeah, and the trends nowadays in modern software development, I think we're going to take a lot of time. Um, I think, but that's okay. I've prepared almost 25 around slides, so I'm going to go a little faster. What trends are there in modern software development is a cloud native application. So nowadays, everybody is developing applications directly on the cloud. Then there is a microservices. Now the big applications are broken into small and independent services, so that if something has to be corrected, only that one piece can be replaced immediately, right? So the maintenance becomes little easy. Serverless, that's where your backend code runs on a server that you don't have to maintain. So your server basically exposes APIs, and whenever and whatever events are there, based on those events, those serverless components will be called. The request will be made. The response will be prepared by the server as in the code, and then that response is returned. Right. So these are smaller units of servers, I would say, which whose server management is not in your control, right? Uh, and AI-driven development is happening nowadays. The way I showed this component, AI component. So a lot of yeah, and during development also there is a lot of AI assistance. So your GitHub Copilot Chat GPT is getting integrated with the IDE, right? ID is the editor in which the code gets written, and there is a lot of help these days. So your AI really reads the code, and then it suggests the next line that has to come, or the current line. Suppose I'm writing some function, and if I only write the comment, then it will prepare the entire function for me. So this is very informative, very useful. If you're not using AI assistants, then I will suggest that please try that out. Low code, no code. This is for faster prototyping. This is typically for applications which have reached standardization stage, right? So in that case, everything is well drafted, well designed, and is structured, right? So you don't really have to write new code for that every time. So you can just drag and drop components, fill in some values, and that's it. So that level of automation, some domain, some projects have reached some more than projects, I would say some problems have reached that there is no new development necessary really. uh, Edge computing is something about running code close to user. So sometimes may happen that you are in India, but you're using the US server, right? So instead of that, edge computing, or maybe there is another example, better example. In ADAS, in automotive industry, what is happening right now? If there is a traffic, right, and those traffic has to like if there are five roads coming in together and there's a traffic signal, and all these vehicles are nowadays software based, so they are sending information to the server and then getting the responses back. Now there could be times that in that traffic control in that square itself, a edge computing node would be kept, so that the requests coming from the local area is served locally, is processed locally. And there could be times that multiple requests from multiple vehicles is processed, and then the decision is taken by the edge computing, right? So those kind of things are there. Yeah, so that's edge computing. I think this would be a repeat. Front end is what user sees and interact. Backend is something that works on the logic, data, and what rules have to live. DevOps or infrastructure is how your application is getting deployed, scaled, and secured. So the same analogy, front end is dining hall and menu, and users sit in the dining hall and they order, right? So there is a request that happens through the menu, and backend will prepare that recipe, and DevOps is the building and electricity and delivery service. Uh, Front-end development core concepts. Okay, I don't know whether we should go in depth with this much of
It
overview.
is repetitive, so you can skip this.
Yeah, yeah, right. Uh, right. So there are multiple architectures in front-end development, multi-page and single-page application. Maybe next time, almost you could take a session on this. Frameworks, we already mentioned few. So React is good about component-based. I don't know really about others. So it's not possible for every, even if I'm working as an architect, doesn't mean that I know everything. There are a lot of things that I don't even know. I just know them conceptually, right? CSS is something which tells the styling. Like even if the button is there, how that button should be styled. Should it be round, or it should, what color it should have. So those kind of things are mentioned in CSS. Um, uh, and state management, every UI application has to do some state management. And state management, as in they have to know at what level your application is running. Suppose you are doing the order management, right? You are on the Flipkart or you are on Amazon, say, right? So the processing is happening on the backend side, but on the front end side also some states are maintained. So that happens here. And in case of Redux, this is for React. Yeah, some states are maintained. So there's a state management that happens on the UI side. Data fetching. Yeah, so there are, so the way I said, the request is made. So usually, typically nowadays, almost every request that goes between client and server is through REST APIs. So this has become a kind of a de facto standard for sending and receiving messages over the cloud. GraphQL is very particular to few applications where your request has to be, uh, altered, because sometimes what happens in the REST APIs is if there are hundreds of fields that the server has to send, hundreds of different data fields that server is sending to the client, but the client really do not need all of them. They probably need only five of them. Then it doesn't make sense for server to send those 100 fields to the client. So that's where GraphQL comes into picture. Real-time data, the way I said, sometimes your server has to keep the connection back to the client and push the data. So that's where your WebSockets come into picture. Okay. Um, Performance optimization. Yeah. So I think this is a very specific topic. We'll not cover this at this point. The thing we already talked about, accessibility. There are various things that can be taken care regarding the semantic, keyboard navigation, how the users will interact. Screen readers are available. The colors that I mentioned for the blind people or the color blind people. Yeah, and with this, there are many tools getting used. There are package managers. So current developers, they will know about these tools. We can, yeah. Testing the front end. There are various unit testing, widget testing, your integration testing that has to happen. The end-to-end testing also takes place. There are many robots were created to create to test the front end or rather in your entire application. So there is a block of like I had seen this. The tablet is kept down and the robot comes and it pushes button, and basically the entire workflow is executed. So this is a very interesting aspect of it. Uh, Deployment and delivery. Static content is there. So in your website or in your web application, there is some content that is static. Static means it does not change. So there could be static hosting done for that, or there could be a CDN created for that. Uh, Future trends is really AI assisted UI generation, web assembly. Uh, this is the execution. Most of the execution has to happen in browser. So that's where your web assembly comes into picture, and that's where your C++ also becomes very important here. Component driven design, and the 3D AR, these are the things will happen, with compute being very fast, the client device itself being very fast. These things are will take shape in near future now. Yeah, then there's a backend development. We have to do the logic, we have to do the database, and we have to serve all of this to uh, to the UI, right? So this is for that. Service will coordinate the logic, business logic, and external systems, right? So if the way I said, there's external third party things, you have to get that data, so that's where your service layer would come into picture. On backend, there are various type of architectures. There's a monolith, like one code base does everything. So this is good for small and simple problems. But when the problem becomes bigger and the multiple modules, then it makes sense to break that into a microservices architecture where your independent components servers are created. Serverless is, again, these are triggered by the event, and the cloud manages the scaling, so you don't have to do anything for auto scaling, uh, like whether to shrink or whether to expand a particular functionality so that it can serve millions of people or 10 people at a time. So that management is taken away from you, and the cloud itself does that management. And event driven, um, is the way I said, there was one component, a message queue. Uh, so event driven, oh, no, no, this is event driven architecture. So event driven architecture is a completely different aspect. It does not really relate to your message queue, though it uses message queue, but the event driven architecture is something like your CA does, or your accounting team does, right? So they record everything. They don't maintain the final state, they maintain all the events that occur and in that order. And some applications, like your banking applications, should be written in a event driven architecture fashion and not a typical uh, other microservices based architecture. I mean, again, event driven architecture will use a microservices architecture, but this is a very important aspect of that, so that the authenticity is kept. Verification of your application has to happen at all times. The data has to be maintained, right? You can't really lose any data. So these things happen in your banking. That's where the event-driven architecture is very important aspect. Yeah, this is about the architecture. Backend languages are used is JavaScript, Node.js, Next.js, Express. These are based on JavaScript and TypeScript. Python, I'm currently making use of Fast API, and I also had some exposure to Flask. In my opinion, Django was a little complex for me. Yeah, I have interaction with Java, Spring Boot, Micronaut is, I don't know, I'm not aware about this. C Sharp, yeah. So your ASP.NET, all .NET frameworks, they have a very common technological layer, and C Sharp is useful in some cases. In ASP.NET, you are developing your front end and back end. It is tightly coupled, but C Sharp is very much about the functionality only. So this is in the backend, and there are other languages. Go Rust is very solid language, and a lot of other languages have learned from Rust. Rust has a very fantastic uh, code readability, and that's where Rust is important. And PHP, earlier days, many people used to use. Even now, I don't know what people do now, but there are many tools that make use of these languages. API layer, we've already covered this. REST is a standard HTTP APIs. There are a lot of incorrect views about REST. Like people say REST like anything, and then they say REST, but they don't use REST. So this is very. But again, this is more like a style of writing code, and this is not really a technology. GraphQL, the way I said, 100 fields are there, but you only want few. So that's where your GraphQL comes into picture. gRPC is when your field structures are not changing very often, and that's where your gRPC comes into picture. So they are very fast. They're faster than REST. WebSocket is for real-time communication. Database, there is a SQL, NoSQL in memory. Redis is a in memory, memcached. And new SQL, I don't know. Yugabyte. Okay, new SQL, they combine the benefits of these SQL and NoSQL and in memory into one. Authentication, authorization. So there are different authentication mechanisms. So the way I said, sometimes you are getting authenticated on Google website and then you are coming to another application like LinkedIn, or LinkedIn may have its own authentication mechanism. There's a session management because every user, there are hundreds and millions of users are connecting to the servers. You have to do the session management, as in you have to maintain which user is which user's request it is. So all of that also happens through your JWT tokens and yeah, cookies as well on the USA. User control, RBAC, role-based access control. So if you take an example of enterprise, there are there are admins, the infrastructure guys, IT folks, there are developers, there are QAs, there are business, there are managers, so different roles, right? So for every different role, there is a different set of resources accessible to them. So that's role-based access. So attributes is like instead of role, you are relying on the attribute, the group that you are in, to give the control, allow the access. Security. So there's encryption that happens. So whenever you are using HTTPS, that means S is for secure. That means your any communication that happens is encrypted basically. And input validation and output and sanitization happens on the server side. Rather, at multiple levels, this sanitization may happen. Rate limiting is to prevent. Suppose somebody writes an application which sends thousands of requests per second. And with that, what will happen? Your server will not have uh, uh, will not be able to process the other important requests, right? So we have to do the rate limiting for that. So this is for that. And secret management, I said there are some things maintained. Scalability, yeah. Suppose there are some requests which are coming more often. So instead of processing them every time by the server, those cache can be maintained somewhere in a cache server, and requests could directly be processed from there, could be responded there if the response is standard. If the request is standard and same fields are being practiced, the same fields response can be sent back. Okay. Uh, yeah, I think we talked about load balancing. DevOps is a separate topic, really, but it is expected that the full stack developer also understands the aspects of DevOps. So that includes your containerization. So every microservices nowadays, a lot of people are using microservices or service-oriented architecture. They tend to make use of Docker. So this is again another standard getting implemented. Orchestration of multiple containers, how that should happen. So this is about that CI/CD pipeline to take the code and deploy it. There are various different things that you have to do, and that happens through your infrastructure as no, your CI/CD pipeline. And infrastructure as code is like if you're deploying something and if you're deploying something many times, then you write a small code which will guide the CI/CD pipeline to go where and do what, right? So that's about the infrastructure. So monitoring and logging. So everything that happens on the server side that gets logged somewhere, and again it is maintained and um, gets utilized at a later point of time. In case of backend, there is a unit testing that has to happen, integration testing, contract testing, and load testing. Contract testing is more like your API testing, right? So more interactions between more components, internal or external. They are working on some contract, and that contract is your APIs, isn't it? Future trends in this is edge computing is there, AI assisted APIs are there. Yeah, so nowadays there's a very important aspect of API documentation itself. So what variables you're using, what is the name of the variable, and what data type it has. So these AI tools can make use of your API documentation and can serve a few requests on their own. So that's where the Gen AI and this agentic AI coming into picture. So it has become very important to write the API documentation. Uh, Fully managed backend platforms. Yeah, so there are platforms which give the databases, services, and many other things, authentication as a service. So you can directly go register and use those services instead of writing those on your own. So this would well, speed up in near future. Yeah, so these are future trends. And DevOps, okay, this is an analogy that we have given. DevOps is like a logistic team of a restaurant chain. So CI is is the supply truck arriving the fresh ingredients every day. How those would come. CD is something like updating the menu across all the branches because we are deploying that menu right at many places and in many units branches. And infrastructure as a code is like a recipe book. Depending on that book, the every building of the kitchen would do the things in the same way. Monitoring is like a CCTV camera where the admins or the console admins they check if everything is okay and is they're tracking that. DevOps overview. I think we are beyond time, right? Uh, Maybe we already had done the DevOps session. Um, okay, we'll just run through few things. So core concept is DevOps. There is SysOps. There is SecOps as well. So there are multiple ops, and they all come under your DevOps. SecOps means your security operations. DevOps is there. Your SysOps is like your systems operations are taken care in that, and CI/CD automation anywhere. Yeah, so they're doing automation, right? So DevOps lifecycle, they had to plan. Again, just like any other software development, for the infrastructure also, for DevOps also, you have to really plan, code, build, test, release, operate, and get the feedback. So this entire cycle is produced, has to be carried out. Infrastructure as a code, there are tools. Terraform is something that I've used, Ansible I've used, Puppet I've used. Benefits, I don't know about others. Benefits is version control infrastructure, repeatable environments. Yeah. Yeah, continuous integration. We are bringing in multiple components together. We are building them, we're testing them before they are deployed, right? So before the deployment, whatever you have to do, that is in CI's bucket. And once your integration, now you see that the integration has happened, building and testing is done. Now it is ready to deploy, and that's where your CD comes into picture. So it could be continuous deployment, continuous delivery is a very different aspect really from deployment, but that's also like they're related. But continuous delivery could be very different than continuous deployment. Continuous deployment's job is only to do the deployment. Delivery is actually to deliver few things in addition to deployment. Or once after the deployment has done, the delivery really should start. So there are few business cases where we should have the delivery as a separate aspect. Containerization, where I said Podman, yeah, this is alternative. So there's a tool which is at the core of Docker and Podman. So Podman and Docker, they make use of that one small utility which makes this thing happen. Um, yeah, then there's orchestration, how these pods will talk to each other, how they'll scale up and scale down, what policies are implemented, where they'll be implemented. All of that would happen through the orchestration of those components. Uh, yeah, so DevOps also, this is an important aspect from DevOps perspective as well. So every log is maintained, and the way I said, there could be different functional units which would process that data and would rather generate alerts, things like that. So DevOps also has to play a role in that. DevOps plays a role in everything because it is a base of front end and back end both. Even your front end is delivered from your servers, right? So yeah, so they are everywhere, and the yeah. So future trends in this is GitOps, Git as a single source of truth for infrastructure and applications, AI ops, AI powered monitoring and incident management, no ops, fully automated operations, serverless, everything serverless, um, and edge DevOps, the way I said, closer to the users or the scenario where the application is getting used. So, yeah, any questions?
You mentioned about containerization, Docker and Podman. You
Mhm.
mentioned some OS level utility and tool is
Yes.
used. But what is name of it? As in, just wondering.
I'll have to find out, but I'll have to find out and come back to you. I don't know that, but
Oh,
there's some utility. I'll come back to you. So that utility gets used in many of the embedded systems or IoT projects. So they can't really afford to have Docker, right? So Docker is huge, heavy, very bulky. So those folks use that thing, that core part of it. I'm very sure now Docker must have evolved that utility as well as their own version, uh, you know, uh, their own repository. But when it started with that. I'll give you the name.
understood. Yeah, sure. Thank you.
Yeah.
It's lots of information, I know, and it takes years and years to at least get to know and then mastering it.
Yeah.
Uh, whenever I suggest any fresher students who tries to come into IT field, I suggest them to study all these things, not in a deep, but at least get to know the concepts and how it works. So they really get scared by just looking at the quantity of the things that they need to study. So how do we prepare them for this? Because
Um,
nowadays we know that full stack is actually a key to get into the IT. I mean, in general, I'm saying, not specifically like you are just a front end developer and you will get directly job, or you are just a back end developer and you are get a job. So those things are already gone. You also need to know other things around it. You might not need to work directly on that, but you should be aware what is exactly going on in the backend as you are working as a front end developer, or what is happening in the front end, who is I mean, why the component is like designed and how it will be shown. So as a backend developer also, you need to take a consideration of that thing also. So how do we convince the fresher students to learn all these things, and that too quickly?
Right, right. I think this is a very important, and even while I was designing this presentation, I was of the view that the attendees are not could be coming from different domain, right? They may not even understand all of this, and that's where learning through analogy is very important. So same thing would be applied. I would suggest the same thing to any freshers who is even in IT. Maybe we could take a case of Vishaka, right? She is new to IT and she is working on full stack. So having understanding at the conceptual level is very important, I think, for them. They don't really have to go in depth and understand how really infrastructure is managed, but they should know what infrastructure is there to manage. Like there is a compute, there's a memory, there's network, right? There's storage. So that's the infrastructure that they have to manage. So even if we know that, that is sufficient. So for the front end, it is important to know how things are done at the back end side, so that when they are designing something, they will uh, they will design it in that fashion. For example, if there are millions of records, you can't really ask for millions of records, from the front end, because to get those millions of records would be very difficult, and to show that your performance is going to go bad, right? So that's where your users are supposed to do the pagination, right? So why pagination is necessary? That understanding the UI person should have. And again, how the pagination is implemented, that understanding they should have. Like how many, again, all of this is a very generic thing. The understanding that you really should be able to apply to the actual problem that is there at hand. So if you're in a company where only banking is done or only healthcare is done, so in that case some aspects are not necessary. For example, if you're in healthcare, maybe the message queue is not necessary, and you don't really have to know about logging and things like that. So even if you should know the entire picture, you and sometimes now I know that the lot of developers, they don't know what happens in DNS, but they know how to create a service. So that's okay, but slowly they should expand their horizon, and should try to understand how and where their component is placed, and what is the implication of that component into with other things. Now that's where I like diagrams more. Now, on this diagram, I know that if I'm a backend developer, which are the components that I'm close to. So if this is the backend, I have to know a few things about databases and the logging, notification, and I don't have to know anything immediately about the web server or the application load balancer, right? So when I'm starting as a backend developer, though it is necessary for me to know what is a load balancer, but I can really concentrate on aspects within this box and the immediate neighbors of this box. Maybe we should be able to limit our scope to that. So first thing is to know how things happen within me, then probably what things happen around me, and then maybe what happens thing around the components around me, right? So we could try to give. So again, this is a continuous learning. This is a years and years of thing. Uh, yeah, and I probably am a junior to you, Amul sir. I've only spent 4 years around time in this domain. Uh, but yes, there is a lot that has to happen. But if you know things conceptually, you can really dive deep into any component and yeah, and start working. So if you ask me, I feel pretty confident to work on any aspect of this. I can work on the front end aspect, back end. I also do this message queues and Terraform. Also, I do secret management. I have done logging, notifications, CDN part, lambdas, the third party, Gen AI also have done. So I've done touched upon almost all aspects of it in these 4 years, really. So it's possible. And nowadays with AI, like ChatGPT, Gemini, whichever is there, things have become very easy. So even when you're writing code and you're stuck, you could really connect. If you have your AI assistant, you just write that comment. Now write, no, include input sanitization. Even if you write that, the AI will know what parameters are then, and it will write the code for input sanitization. Yeah. uh, yeah, I think we this is a lot to take. This is very scary. There are hundreds of concepts here. But if we give them the analogy, I'm again summarizing. If we give the analogy of a restaurant, that's, I think, best to explain this at the conceptual level. And then the association of the analogy and the actual thing has to happen. And for all of that, we could limit our scope. We should look at the broader picture, then go a little closer, then go a little closer, and then look at things. That should help. Yeah, those are my 2 cents. I think Rahul sir could, yeah, yeah.
Yeah, there was actually one candidate
Mm.
um, who wanted to become a data analyst and also a data scientist. So I asked her, have you studied the operating system first? Because everything starts with the operating system. If you are
We can't
learning
explain.
with
Uh,
ah, I I asked her that you are dealing with the files using the Python and Pandas, right?
right.
But when you process that, where exactly that file is getting stored and how it is understood by the operating system. So she was confused. Why should I learn the operating system when I am in the data science or data analytics? So I suggested her to please study the operating system basics. It will not be what we can say a straightforward in your career, but it is important you to know what exactly happens behind the scene.
Right. Yes. Definitely. So these are very small. Yeah, there are many components, and you really have to do specialization on few. But it is important to have ability to understand everything and provide your inputs. Suppose there is a DevOps person, right? So DevOps person should also be able to contribute and give inputs while the UI development is going. Like your what infrastructure they need. So again, in that case, all the developers become clients, and DevOps really becomes the infrastructure
Right.
manager. Right?
And only one point I would like to add for the freshers candidates specifically, or maybe experience as well. So when you are getting any chance to work as a junior engineer, you should not focus only on your work, but try to expand your knowledge and understanding with all the things. Maybe you can do your own projects at your home, but try to understand all these things. It may not be directly related to your current role or maybe future role, but it will certainly help you to understand overall picture of the project, of the applications entirely.
Right. Definitely.
So think in that way.
Yeah, definitely. Any other questions? Yeah, I got this prompting. Nikhil Tide, sir, you mentioned about prompting. What was
So you were on the point where you were saying that AI is, you were on the AI point. So that is when I mentioned that
yeah, yeah,
prompting
prompt
will be.
engineering, right? Yeah, yeah, yes. Again, there is prompt engineering. Now there is context engineering, many concepts, many things. There we could have another session about prompt engineering and context engineering as well. That's majorly in terms of RAG applications or AI-based applications. We could cover them in some other session. Yeah. Any other questions? Okay, I guess that's it. Thank you.
Yeah,
So much.
if
Yeah,
there are no
thank
further
you, thank you.
questions, then I would like to thank you, Prashant sir, for delivering such a wonderful session.
Thank you.
Thank you,
So
sir.
much. Thank you.
We can close the meeting.
I would like feedback about the session. So, if not now, later on, or
Yeah,
collect the
I will
feedback right away. That
stop
would
in the recording.
recording.
Sorry, I don't have rights, I guess.
Yeah,
Can you stop?
I'll do.